All right, guys. Let's do our thing, learn some more command, and keep having fun. So today we're going to talk about some special permission. So I went ahead and create some user and group here. If I do cut inside the ET group, you see here I have a group that I call today, and I have two users that I call Peter and Django. So if I and here I'm logging as a user Peter. So if I go ahead and I create a file that I will call two, for example, if I do lm, what is the permission of the owner of that file is root and the group is root. So if I do change group and I want to give the group of today to know, and I'm giving that to the file too. If I do here, I will see that the owner of the group is two. And we also know that Peter is the member of the group too. So that means Peter have some privilege on that folder, right? And also, guys, excuse me if I keep and say folder and file and miss both of those things. Sometimes, in my mind, I know what I'm saying. It just like it just come out of it, and I hope you guys, follow me and understand what I mean. So, here I was saying Peter, since he's a member of the group today, that means he has some permission on the folder too. So let's try to cd inside the folder too with Peter. So Peter is able to go inside that folder. Why? Because here on the group, the permission X is set. The X permission is what give the possibility for somebody to CD inside the folder. Is the X folder. So you guys can go back and watch the first video when we were talking about the permission to kind of say. So since the X is set up, Peter can go in. But what happens if Peter try to create a file? Peter want to create a file 3. Here is being denied. Why? Because the permission that allowed to create a file is the W. Here, the right is not set. That's why people cannot create a file. So if we do chmod and we to the root, coming to the group, we use the right permission to the file too. What's going to happen now is that Peter is going to be able to create that file, that folder, sorry. And if we do LL here, what happens? Peter create the folder. Who is the owner? Peter. What is the group? Peter. Why it doesn't go as today? Because it's defined like that by default. Whatever who create a file or a folder, he automatically own the group of that file automatically. If you want to change that, what you need to do is to set what is called the group ID. So we need to set the group ID. That's the special permission. So that every time that something going to be created inside the group today is automatically going to set as a group today. So to do that, we need to do a chmod on the group. We want to set the GID permission on that folder too, right? If we do LL this time, what do we get? Here, you don't see the X number. The X is there, but what you see is an S. This S is to notify you that this file is set as a, set group ID. Automatically, every file that's going to be created inside this folder is automatically going to be assigned to the group today. So as a Peter, let's go again and have Peter create another file. So Peter do make the and he want to create a file that he's going to call for. And when we do LL, what happens? That file that Peter created, automatically the group is set to today. Why? Because we have set um, the set group ID on it. Every file that's going to be created in here will automatically have the thing as student. So if we go in there inside tool and root decide maybe you want to create a file that you're going to call 6.sh, you're going to make a small script and he want to print the date and he want to print the calendar, right? What happens if we do ll, we have our file that we created automatically. The group belong to today, as you can see, right? So we need to give him the execute permission. We do chmod on the user. We want to give the execute permission on that file 6. Now you can run your script. Bam. Right. If we do ll here, we see that we have the script. But what happened? This guy 6 cannot run that script. If I press S thing, I can't run it even I'm part of the group. It said permission denied. Why? Because we need to set, in this case, what is called set UID, you know. So to give everybody the permission to run that script as if he was root, you know, basically that's what it means. To do that, we use our command chmod, and on U, we give the S permission, and we are giving that S on the file 6 here. But still, mind you that even though we have gave it, we also need to, give that execute permission on the group, because we know it's the execute permission that do the job. Because if I record that command, it says permission denied. So to that, I'll do chmod, and on the group, we want to give um, the execute permission on that file 6. And if we do ll, we still now we see that that file have the execute permission. The file can run already. Pay attention here. What happened? Now we see that the group can, execute that file, and he's executing that file with the permission of root in here. So basically, what is happening? How when you set the thing of the group, set the user ID, everybody can execute this file as if it was root. And here, if we decide that we want to create some more files, let's say we're gonna touch, or we're gonna touch 7. We wanna also touch um, 10, for example. If we do ll, we see all those files that we have created belong to the group today. This file 7 belongs to the group today. Now, what will happen? This guy Peter can decide to remove one of those files. If Peter want to remove the file 10, when he press enter, Peter can remove it. And remember, that file didn't belong to him, but he was able to remove it. If you want to prevent that, if you want to make sure that only the person who is the owner of the file can delete it, you need to add what is called a sticky bit. For that, we do chmod, or chmod plus T on the sticky bit. On we need to do that on that file too, right? So we are putting the sticky bit on that file too still. When we do ll, oh sorry, I needed to do the ll on the file too here. Sorry again. So when I do the ll here, we see here that on the file too, the permission that is set also you say there's a T here. In this case, if this guy want to delete the file here again, like if we say remove on the file, I believe we have left 7 now. It said you want to delete. When you press yes, what does it get? Operation not permitted. He cannot, execute that permission. Why? Because we have set a special permission that say it's only the owner of the file who can delete that file. So those are what is called like the special permission on a Linux system. So to have a better view about it, like here, when we talk about the set UID, to implement the set UID, you can do user plus S, or either you can use the numeric way that we know. You add 4, and then the 3x here represent the normal permission that you know. So that permission might be 77, or maybe it might be a 765. It depends on how you want to set it. So that's how we go for the set UID. The set UID gives everybody a permission to execute the file like they were the owner, as same as the owner of that file. To set the set GID, we need to do G plus X. The S here, gonna stand for 2 if you want to do the numeric way, and here the triple S gonna be the normal permission that you know. The sticky bit here, that's how you do it. You just do a plus T, or if you want to use the numeric way, it's 1, and you have your normal permission that we know. So that was like the special permission that we needed to add today, and start practicing and have fun with it. The other command that we're gonna add is gonna be what is called file access control list. The file access control list is a way to just imagine in the case you have a project to work with one person, and that person does not belong to your group, but you guys need to work on the project together. So you can create a file and you give permission to that person so that you guys can, do your thing together. And in this case, for example, let's say we're gonna get out of here because we know the permission that is set there, and here we are talking about something different. Let's create another file that we're gonna call maybe over here we're gonna call it 10. I'm running out of you know, the name to come with those files. If I want to set, if I want to see what are the permissions that are set on that file, I can use what is called get file access control list, right? On that file 10. When I press enter, it's telling me here the name of the file is 10. The owner of the file is root. The group of the file is root, and here's the permission that comes with that file. So imagine that I have a user um, Red Hat, because I know I have a user Red Hat on this server, and I'm supposed to work on a project with him. I need to give him some permission on that folder 10, for example. To do that, what I need to do, I need to set file access control list, and here I'm I'm making a modification on the user, user Red Hat. And on that user Red Hat, maybe I want to give him the read and write permission, for example. And I'm giving him the read and write permission on this file 10. Right. By the time I press enter, the permission I set to that user, and we can start working on the project. If I call back again that command, you see we have the same thing that we had before, but now we have an extra permission that is being added, that that user Red Hat has to read and write permission on that file, and he can start doing his own thing, and the other permission are kind of set how we know. So we always know that we have our beautiful man page. You can always do man get file access control list to have a more nicer way to walk around with this command and being more confident of what you do. Like for example, the recursive that we see here is just kind of gonna mean every other file that we're gonna create inside the folder 10, the permission gonna automatically be um, assigned to Red Hat. So if I press enter, let me go inside 10 and inside 10 and make the another file that we call 1010 for example. And if I do a get file access control list 1010, what do we see? Um, did I miss something? The file is 1010, so get file access control list. Yes, maybe I need to make sure I'm here from the home directory before I do that. And now if I do, I'll call that file again and, and here now the permission is set to Red Hat at the same time automatically on that file 1010 as well. So this is kind of how you can play with that and give permission to like a different user from a particular command or a particular project that you're going to be having around. And those are some more commands we need to play with. To also go more in deep, every time you run a command or on your computer, there's a lot of processes that is working in the background. The process is basically every single thing that is happening on the computer. When you type a command, there's a lot of things that's happening in the background to make that command, give you an output. There's a lot of like, agent like inside your command to, that is working in the background, for example. And if you want to see what are all those things that are working in the background, which we call process, we use the PS command. The PS command, we can always do man on PS. Here it's going to report a snapshot of the current process. So the processes are like things that work in the background and it's going to give you a bunch of information on what is happening on your computer, how the computer is behaving, and all those things, where did it come from. And this is one of the commands that we use a lot for troubleshooting. So if we do TS, for example, and the variation that you're going to see, the more is going to be AUX. The A here stands for all, show me all the processes, and the U stands for user, show me also all the users that are running those processes. As you know, here I have the user Peter, I have Django, I have Red Hat, and all those users. Like show me all what they are doing on the computer. And here the X is just a word that stands for process that run on this terminal at the moment. So when I press enter, it types me a bunch of stuff. We know here Apache is for our website. That means I have a website that is running here, and that website have a process ID. The process ID here that is running, and it's giving me a bunch of information, and it's showing me what command is typing from my computer, from where it's come from. We're gonna kind of see that from the top. So let's type it on less. So from the top here, we see on the first line is give us the user, which is all this first line. The second line is give us the process ID, and the process ID is the first process ID is always a system D. It used to be init, but now it's system D. Here it show me the amount of CPU that this command is using. To do his job, he gotta use some amount of command. Here that the memory that is taken on the server, like all this information is kind of critical. We're not gonna go in deep about it now, but it kind of give you an idea already, like a process, what the process is doing, what is happening on your computer, like all those commands they need to do your stuff for your computer to be able to run properly. You know, it's kind of bunch of them. It's a lot of information. The more we're gonna see them, the more we're gonna talk about it, the more you're gonna get familiar with what is going on. So when I do the PS command, he showed me, he gave me the information of what was happening on the computer at the moment that I typed that command. So that means from the moment that I typed the PS command like 2 minutes ago, things are keeping happening on my computer, but you know, it means maybe the information that I see is not the more accurate no more because the time doesn't stop. Things are keep on doing their stuff in on the computer. So if I want to see what is happening on my computer in real time, as it's happening, I want to see what is going on. We use the top command. So top going to show you a bunch of information and also the processes like we were talking. The first the first process ID is always system D. And here you see the computer show that I type the top command is going to come here. So the top command that I type, that is his process ID. That is kind of showing all the time. The process ID, his process ID is coming back and forth. So like all these things is going to be like different command that is happening on the computer and it's working on the background. It's kind of showing you what is going on, who is doing what, who is who, what is the process ID that is having, and all those extra stuff. From so if it's happened, like I see that there's a process that is doing too much work. Like let's say for example, to get out of here, by the way, I just press a Q. But let's imagine if I want to do a yum, um, I don't know if this will work, but let's do a yum check. I'm going to split the computer in two so that you can see exactly what's going to happen. And let me SSH in that machine. Okay, in this case, I want to do yum. Let me run my top command here first. Um, Let me log in as well. I want to just make things easier for us to understand and see what is going on. Make it a little bit bigger and I'll run my top command. Right. And on this other side, I will do yum check update. By the time I press the enter on yum check update, just look here, it's just saying yum had just started the process and that process is 7275 and Yum was doing his job and whatever what he's doing, the computer is showing us. HTTPD is doing his thing also. Like all these processes is happening in the background and for us, like we can just see just right there. Um, I'm pretty sure whatever what command you type, the more a command is using a lot of process, is using a lot of power to execute whatever what he had to do, the more is consumed like the CPU, the more it's consumed the memory and the more it's come on top. And this process and all those things is might happen like you might want to kill some of them and we're going to talk about it how you can kill it and stuff. But what I want you to get now is how would you like see a process that is running first and have a better idea of what is happening on your computer while you are typing those commands and while you are doing all those things. So if we do maybe make the let's say 10 10 10 and say uh, I guess since that command doesn't use some a lot of resources to kind of being executed. That's why we didn't see it quite on the top directly. But trust me, he did appear and he did do his thing. So guys, play around with this command that we talk about today. That was the set UID, set UID that we talk about. We talk about the set group ID. We talk about the sticky bit. We talk about the sticky bit. We talked about the get file access control list and the set file access control list. We talk about the PS command for processes and top for processes in real time. So do your thing and keep having fun. All right, guys.